What if the ground beneath your feet isn't as stable as you think? What if right now, deep below Earth's crust, something massive is rising and scientists can't stop it? For decades, humanity has looked up at the stars searching for threats from space. Asteroids, solar flares, distant supernovas. But the latest data doesn't point to the sky. It points downward, far below our cities, our oceans, our continents. Something is moving, slowly, relentlessly, and according to recent geological monitoring and satellite measurements used by NASA-supported research networks, the signals are impossible to ignore. It began with subtle anomalies, slight shifts in Earth's gravitational field, almost undetectable. Satellites designed to measure planetary mass distribution started recording microscopic changes beneath specific regions of the crust. Not noise, not instrument error, patterns. Then came the seismic whispers. Not earthquakes, not yet. Just faint tremors, low-frequency vibrations that didn't match known tectonic signatures. Too deep, too slow, too organized. Scientists studying mantle dynamics recognized the pattern immediately. And it sent a chill through the geophysics community. Because those signals usually mean one thing: movement from below. Deep inside Earth lies the mantle, a vast ocean of semi-molten rock, constantly circulating in slow convection currents. Normally this motion is gradual, almost imperceptible, shaping continents over millions of years. But sometimes heat builds faster than it can escape. Pressure accumulates, and when it does, it forces material upward through the crust like a rising breath trapped beneath stone. Geologists call these upwellings mantle plumes. They are rare, powerful, and when they reach the surface, they can reshape the planet. Satellite radar interferometry, technology capable of detecting ground deformation down to millimeters, has revealed subtle bulging in certain remote regions. The land isn't cracking yet. It isn't erupting. It's swelling, like a slow heartbeat beneath our Earth's skin. At first, researchers assumed localized magma chambers. That's common in volcanic regions, but the scale didn't match. The uplift spans areas far larger than any known magma reservoir, hundreds of kilometers across, expanding, which means this isn't a surface phenomenon. It's deep, and it's rising. Scientists analyzing seismic tomography, essentially CT scans of the planet's interior, have begun mapping columns of unusually hot material ascending from the lower mantle. These structures aren't theoretical. They're visible in wave speed data recorded from global earthquake monitoring stations. Where seismic waves slow down, temperatures are higher. And in multiple regions, those slow zones form vertical pillars stretching toward the crust, columns of heat, towers of molten rock. Silent, but climbing. Some researchers remain cautious. Geological systems are complex. Earth has always been dynamic, but others are more concerned because the speed of change matters. And in several monitored zones, uplift rates have accelerated over the past decade. Not dramatically, not violently, just enough to be measurable, just enough to raise questions. And questions in science are often the first sign of something bigger. If a mantle plume is rising, the crust above it begins to weaken. Rock softens under heat, pressure fractures form, gas accumulates, eventually pathways open. Sometimes the result is volcanic eruption. Sometimes it's a massive flood basalt event, lava pouring out over thousands of square miles for centuries. The last time something like that happened on a truly global scale, it nearly ended life on Earth 252 million years ago. During the end Permian extinction, enormous volcanic outpourings in what is now Siberia released unimaginable volumes of lava and greenhouse gases. Temperatures soared, oceans acidified, 90% of species vanished. It remains the most devastating extinction event in planetary history, and it started underground. Today's signals are nowhere near that scale, not yet, but the physics behind them is the same. Heat rises, pressure builds, rock yields, and NASA's Earth-observing satellites weren't designed to predict geological catastrophes. They were built to study climate, gravity, ice loss, atmospheric chemistry. Yet their instruments have become unexpected witnesses to subterranean change, tiny variations in elevation, minute shifts in mass distribution, subtle thermal anomalies visible only in infrared wavelengths. Individually, each signal means little. Together, they tell a story. Something is pushing upward. And the deeper scientists look, the more complex that story becomes. In some regions, GPS stations anchored to bedrock have recorded vertical motion measured in fractions of an inch per year. Insignificant to a passerby. But to geophysicists, it's a fingerprint. Solid crust doesn't rise without cause. Something beneath it must be forcing it upward. The question is what? Molten rock, superheated fluids, expanding gas reservoirs, or a full mantle plume head nearing the lithosphere? Each possibility carries different consequences. Best case scenario. The pressure dissipates slowly, the crust fractures gently, heat escapes through minor volcanic activity. New landforms appear, the planet exhales and stabilizes. Worst case? The system crosses a threshold. Pressure exceeds rock strength. Fractures link together. Magma surges upward, and what was once a silent geological process becomes a surface event. Sudden, explosive, and impossible to stop. History offers clues. Iceland sits directly above the mantle plume, so does Hawaii. Yellowstone rests atop another, one responsible for 3 colossal eruptions in the past 2 million years. Those eruptions were not ordinary volcanoes, they were super-eruptions. Continental scale events capable of altering global climate for years. Yellowstone today is calm, monitored, studied relentlessly. Yet even there, the ground subtly rises and falls as magma shifts below. A reminder that beneath every stable landscape, Earth is always moving, always changing, always alive. The difference now is that modern instruments allow us to watch these processes unfold in real time. Satellites orbit every 90 minutes. Seismic stations listen day and night. Algorithms scan incoming data for anomalies human analysts might miss. The planet has never been more closely observed, and still, mysteries remain, because not all rising signals behave the same. Some fade, some intensify, some migrate laterally, as if redirected by unseen channels beneath the crust. In a few monitored areas, uplift has slowed recently, only to resume months later with slightly greater intensity, like breathing in, pause, pause, as if something enormous is gathering strength. Researchers hesitate to sound alarms prematurely. Geological change is usually slow, and predicting exact outcomes is notoriously difficult. But caution does not erase concern, especially when multiple independent measurement systems point to the same conclusion. Deep subsurface movement is happening right now, and humanity cannot influence it. No technology can cool the mantle. No machine can relieve tectonic pressure. These forces operate on scales beyond engineering, beyond politics, beyond control. We can only observe, measure, try to understand, and prepare. If rising mantle material reaches shallow depths, warning signs would appear: increased seismic activity, gas emissions, ground cracking, localized heating. Scientists monitor all of these indicators continuously. Early detection systems exist precisely because geological events rarely strike without hints, but hints can be subtle. and time between first signal and surface event can vary from centuries to weeks. That uncertainty is what unsettles experts most. Not immediate danger, not imminent catastrophe, uncertainty. Because uncertainty means questions. How large is the rising mass? How fast is it moving? Is it a localized plume or part of a broader mantle reorganization? No one knows for sure. And in science, the most unsettling phrase isn't "we're doomed," it's "we don't know yet." Across research institutions, teams are refining models, feeding new data into simulations, comparing present readings with geological records stretching back hundreds of millions of years. Patterns are emerging, but patterns are not predictions. Earth has surprised scientists before. It will again. The planet does not follow human timelines. It follows its own, deep time. In that timescale, continents drift like clouds. Oceans open and close. Its mountain ranges rise and vanish. Entire ecosystems appear, flourish, and disappear without leaving more than a thin fossil trace. What we call stability is often just a quiet interval between transformations. Right now, we may be living in one of those intervals, a calm chapter, a pause. Beneath us, rock is flowing, heat is climbing, pressure is building. Not dramatically, not violently, just steadily, patiently, inevitably. And satellites keep watching. Every orbit adds another layer of data. Every seismic pulse adds another clue. Every measurement brings scientists closer to understanding what is happening miles below our feet. Yet the deeper they look, the more they realize how much remains hidden. Because Earth's interior is still one of the least explored frontiers in science. We've mapped the surface of Mars more precisely than parts of our own planet's mantle. We've sent probes beyond the solar system, yet we've never drilled more than a tiny fraction into Earth's crust. Everything we know about the depths comes from indirect evidence, waves, signals, distortions, shadows in data. And right now, those shadows are shifting. Not dramatically enough for headlines, not violently enough for panic, but unmistakably enough that experts are paying attention, watching, waiting. Because if the rising continues, eventually the crust must respond. No one can say when, no one can say where. But geology teaches one lesson again and again. Pressure does not disappear. It releases, sometimes gently, sometimes catastrophically. And when it does, it reminds humanity of a truth we often forget. This planet is not a static stage built for our civilization. It is a living system, dynamic, restless, unpredictable, the ground we trust, the continents we build upon, the landscapes we call permanent, are only temporary arrangements of stone floating atop a sea of fire. Right now, that fire is stirring, silently, slowly, rising, and somewhere deep beneath the crust, far beyond the reach of drills or cameras, forces older than life itself are shifting into motion. We may not feel it today, we may not see it tomorrow, but the instruments are clear. Something's happening below us, something powerful, something ancient, and whether it changes the world in a century or in 1,000 years, the Earth is already preparing. The only question is, are we?